Hey guys, this is another video tutorial on application of DFS. So in this video tutorial, we're going to learn how to use depth first search to identify the flag of any country. We're not going to use any image processing libraries here. So let's get started. So first thing I'm going to do is I'm going to use one library, but this library is not related to any image processing libraries, right? I'm going to use the library called EasyBMP. So this library is used to read BMP files. So what I'm going to do is I'm going to copy all the files from this library. So if you just type EasyBMP download in Google, then you should be able to find this file. So once you do this, let's create a project. I'm going to name this project detect country flag, maybe. Then I'm going to name this Segwin. Okay, finish. And I'm going to paste all the files that I copied here, right? This is something that we'll be using in our file. Okay, so now I'm going to make a main file here. Okay, so next thing we're going to do is so if you want to learn a little bit more about DFS and how to use EasyBMP library, you might want to see my first video. That's the video that I made where I used DFS to detect the number of islands in the ocean, right? So here we are not going to go into that much details about EasyBMP library and DFS. So let's get started. We'll just focus on how we can use DFS to detect the country flag, right? So we'll need stream. Then we might need conyo.h. We will need vector, right? And we also might need algorithm. And so this one is easybmp.h, right? Let's check if everything is working correctly. All right. Okay, so let me go and change. So this is something that I have to do for Eclipse, but you don't need to care about this if you're using your own own ID. So I guess you guys can set up your ID, right? So let me compile this. Okay, and let me use this. Okay, so success. Although the spelling of success is not correct here. Okay, now what we're going to do is the first thing we're going to do is we are going to read the image file. Here I'm going to create a class called BMP and I'm going to name it BMP, right? So let me make one thing clear here. There are only few things. I think we'll be using like 4 functions from this library in order to detect the flag of a country. I mean, like, we won't be using anything related to image processing. In fact, this library doesn't have anything related to that. This library will be using this to access the BMP image files, right? And the functions that we'll be using is this one function called read from file, right? So we'll be using this function to read the file from the directory, right? We might be using another function called tell width and then tell height to find out the width and height of the image. And then we'll also be using the one more function called get pixel. All right, so get pixel will give us the color values of the specific pixel that we want to use. So let's go back, let's delete this, and delete this. So let me write bmp dot read from file, and we're going to name the file name. All right, so let's call it flag.bmp, but we have no file name called flag.bmp, right? So now we're going to go to our directory. So my directory is hobby and then YouTube, and then this is the directory, detect country flag, right? I'm going to create a new image file here. Is there an image file? Okay, so I'm going to call it flag.bmp. Let me see if I can. Okay, never mind. We're going to delete this and then we're going to go to MS Paint. We are going to decrease its size. Let's say this much should be fine for us for now. And let's create one flag. Let's make a flag of Indonesia maybe for now, red and white. I'm going to save this, and then the path would be hobby YouTube, and then I'm going to name this flag.bmp, right? So 256 bmp, save. Okay, this should work, I think. Okay, so if we go back here and write down cout bmp dot tell width, then it should give us the height, I mean width, and then bmp dot tell height. This should give us the height of these the image. Let's see if this works. Okay, so 193 and 106. Let's check, and yes, it's 193 and 106, right? So this one is working fine. Now let's move on to the interesting part on using DFS to detect the flag. Further, so the first thing we need to do is we need to find out the total number of bands, right? So the total number of bands, let's call it total bands, and then I'm going to pass the image and note that I'm going to pass the information about the image by reference, right? Because these data might be used, right? If I have a large file, then let's say MB of file, then I don't want to create a local variable with that takes that much space every time. So it's better if we call uh, the function with a reference parameter. It's safe that way. So now let's find out the width. Width is bmp dot tell width, and then height is bmp dot tell height. uh, Tell height. Right now what we're going to do is we're going to run DFS function here. In order to do that, we'll have to traverse to each and every pixel. So we're going to go from I0 to I less than width, and then we're going to increment this every time. We are also going to go to the row and then the column. Now what we're going to do is we need to check. I'm not going to explain that much about DFS. If you really want to know about that, then I would request you to check my previous video on counting total number of islands. For now, what we'll have to do is we'll have to keep track of how many pixels we have visited, because we don't want to make things redundant, right? So what we're going to do is we're going to create a two-dimensional matrix of boolean, and we're going to call this visited, right, to keep track of how many pixels we have visited. We don't want to visit same pixels again and again, right? And so this is the two-dimensional. I created two-dimensional array visited with its width as width, and the width comes from here, and then the height, and I'm going to initialize that with false, which means that initially I'm going to assume that none of the pixels are visited. Right now we're going to check if the pixel is not visited. If visited I and j, right, if not visited I and j, then only we're going to pass the DFS. Right, so we might have to pass the image in here, and then width, height, right, and then the current value of I and j. This is something we're going to pass, right? Oh, we also need to pass the visited. Now let's create a main like the main logic behind how we detect number of stripes in the flag, right? So this one is called a DFS. So I'm gonna use DFS. Let's make it a non-return type function, DFS. The first argument is our BMP image. The second one is the width, and then it's the height, then current position, and the last one would be, again, I'm going to pass this as a reference, right? So this will be our function. And now as soon as we enter inside this function, we're going to mark this pixel as visited. We're going to mark this as visited, and So now if this is confusing, it might be irritating for some of you, but if you don't understand this, I would suggest you to just go back and see previous video. What I'm trying to do here is let me open one more MS Paint. So let's assume that we have this image, right? And so let's say it's like 1, 2, and 3 image that's 3 by 3 pixel, and I mean 4 by 3 pixel, right? So if we are checking this pixel, right? So what we're going to do is, if we go back to our previous image here, we want to see how many bands are present in this flag. There are 2 bands right over here. So what we're going to do is, if we take any pixel, we want to see all around if any of the pixels are similar to the pixel that we are currently at, right? So for example, let's say this one is red pixel, right? So what we're going to do is, we're going to check all its neighboring cells. Like there are 8 neighboring cells, right? 3 over here, 3 over here, 1 here, and 1 here. We're going to check all these neighboring cells to find out whether any of these are R, right? If any of those are R, then it's connected, right? These 2 are connected. These might be R as well. So what we're going to do is, we're going to recurse these functions as many times as we find the same color, right? Which means that if we start from the first point here, we're going to traverse all the way down till here, and we go back and then again start from the second pixel. That's the depth first search, right? So let's go back here, and so isSafe function is going to check whether it's safe to traverse to that position. For example, like we would want to check all these 8 neighboring pixels, right? But when we are not going to start from the middle pixel, right? We're going to start from this one. So when you start with the first pixel, there are no any pixels on top left corner, right? So if you try to check this one, then the program is going to throw error. So you need to make sure that you are on safe side. So this function is going to check whether we are on safe side or not, right? So what are we going to pass on safe? So definitely BMP, right? And then we're going to pass width, height, IJ, and visited, right? If everything is safe, then what we're going to do is, we're going to traverse if everything is safe, then we're going to traverse. Wait, we don't need to check whether I and J is safe or not. Wait, so I and J is okay. So we gotta name this something else. Otherwise, there's because there's I already, and then this one can't be I, right? So now let's create 2 masks for finding out the address, I mean like the location of these 8 pixels, right? So first one is X. Let's complete it for X. So let's call it X mask, and this one is going to be, first it's -1 and then 0 and -1, right? So, and then goes -1 and 1, then goes -1, 0 and 1. Okay, this one should be 1, -1, 1, and then 1. Okay, so this is it. And then we need to create a mask Y. The first one is negative of 1, negative of 1, negative of 1, comes 0 and 0, and then comes 1, 1, 1, 1. So these are the values of the four cells, neighboring cells, right? The first one is -1 and -1, right? Which means that, so if I'm currently at this pixel, then -1 and -1 is going to be this pixel, right? And then the second one is going to be 0 and -1, right? So let's go back and then see. So this is 0 and -1, right? So let's check if x mask x, if this is safe, plus not x mask, y mask x, right? And okay, so now if this is okay, then we'll have to pass I plus x mask x, comma z plus y mask x, right? This might be a little confusing, but trust me, it's not as complicated as it seems if you understand the DFS function. I mean, like algorithm, it shouldn't be that hard. Let's see if everything is good until this point. Okay, there are 4 errors. Let's check. Okay, so we missed one bracket here. Let's check one more time. 3 errors. X was not declared. Why is X not declared here? It's not if. This is for. Let's check one more time. Okay, so one more error here. Line 30. Oops. So missing square bracket. Now let's check. Final error. So what does it say? Is safe. Oh, okay. So we haven't created the function is safe. So now let's create a function is safe. What is it going to take? It's going to take the reference to the image file, and then it's going to check the width, height, and current position of the a pixel, and then the value of the visited thing. So what we're going to do is we're going to check return if x I is greater than or equal to 0, then it's safe, right? And y is greater than, not y, j is greater than or equal to 0, and I is less than width, and j is less than height, and we also need to check if it's not visited, right? So what's not visited? I and j. So if all of these things are safe, then why do I miss this thing? If all of these conditions satisfy, then it's safe to traverse in that function, right? So let's check if this is working now. Okay, so one warning. What is this? No written type. Okay, so let's just return 0 for now. And okay, so everything is working until now, right? Now let's just try to check how many bands are there, right? So let's say bands equals 0. So one thing we know is, so once it goes inside this function, it's only going to come out of this function once it traverses through all similar colors, right? and then next time when you go through another pixel or another color, then we need to make sure that it traverses through all those color before it comes out, right? But we haven't done anything about colors until now, right? How would you know that? How do we know that um, it's the same color, right? So let's create one structure to define the color, right? So for now, what we're gonna do is let's create a property for the color. I'm gonna call it struct color properties, right? And what we're going to have here is, for now, let's name it the color type, right? And then the other thing we're going to have is, well, we also need to check whether this color is vertically aligned or horizontally aligned, right? So if it's true, um, if it's then true, then vertical, okay, else horizontal, right? So what we're going to do here is, this structure is going to store two things. One, what kind of color this is, and it's also going to save whether this stripe is horizontal or vertical. In this case it's horizontal, right? But some country flag also has vertical stripes, right? So this one is only to store those two data, right? So now what we're going to do is, when we go inside this band, first we're going to create the color properties CP, let's call it CP. And so if the pixel is not visited first time, then what we're going to do is, we're going to name the color type equal. Okay, now we have one problem. How do you find out which color that it is, right? So if you go back here, it's not pure red. I don't think it's pure red. Let's go to edit colors. See, so this one is 237, 28, and 36. How do you know if this is red? So one basic thing is that if it's red, then it'll probably have this red element more than green and blue, right? So we know that for sure. So what we're going to do is, now we're going to create one more function that will help us define what kind of color it is, right? So let's say get color. So get color is going to give us RGBA pixel. So this structure RGBA pixel comes from the BMP library. So this is the last function, I think, or structure and function that we're going to use. So for red, what we're going to do is, if pixel dot red is greater than pixel dot green, and if pixel dot red is also greater than pixel dot blue, then this function, I mean, like, this color probably is red color, right? So for now, let's just call it red color. We need to define this one later on. Else if pixel dot green is greater than pixel dot red, and pixel dot green is also greater than pixel dot blue, then probably this color is green color, right? And the last one, else if pixel dot blue color is greater than pixel dot red, and pixel dot blue is greater than pixel dot green, then probably this color is blue color, right? So but now we haven't defined red color, green color, and blue color. So let's also define these three colors. Let's call it define red color. We're gonna call this 1 for now. Define green color. We're gonna call this 2 for now, and then could be anything. We'll call this 3, and then let's also make another unknown color. Let's say 0. All right, maybe we would want to keep this somewhere up here. And then I think we also need another color, white, maybe, because a lot of the colors have white in there as well. So now how do you find out which one is white? So white is pretty simple, right? So if all the pixel have the highest value, that's it, it's 255, and pixel dot green is 255, and also pixel dot blue is 255, then this has to be white color, right? So now this we've created one simple function that can return, otherwise it's going to return unknown color, right? So we've created a simple function that will return what kind of color it is, right? So if we go down now, if we go down to the where is that? If we go down here, what we can do is we can find out what kind of color this pixel is, right? So for that we're going to use get color function that we just created, and we're going to pass in here the function called get pixel, right? So get pixel and I comma j, right? So what does this function going to do? What is this function going to do? Get pixel ij, it's going to return the current color value, right? For example, here when we start with this function, it's going to return the value of these three values, 237, 28, and 36, right? From all these values we need to find out if it's red or not. So how do you do that? So what we do is we pass that to the function we just created. Let's get color, and when you go inside this function, this statement becomes true. Red is greater than green and red is greater than blue, which means this color must be probably red, right? So we're going to store that over here and then pass it to, now we're going to modify this function for now, the DFS. We're going to pass this CP function for now, I guess. Let's check. We might have to modify this later on, I'm not sure. But for now, we would definitely need this function. So we need color properties. Let's pass this by reference as well for now. Same thing here, I guess. Color properties. This one goes by reference as well for now. Now we'll have to modify this as well. CP, same thing here, CP. Now what we can do is, so if you go to save here, it should only be safe if it's the same color, right? So what we can do is, if CP dot color type equal let me think. If the current if the color type is equal to the current color type, right? So how do you know what current color type is? So we can say get color, the function that we just created, and then here we might need BMP, right? So we never used this function before, but now we need it. So that's perfect. Then we say get pixel, we check this one, right? Very good with, I don't know, maybe let's compile this and see if everything is working. Okay, what does it say? There's something's not working here. Oh, okay, so we need one more and in here. So this will work. Just check. Okay, so everything's working except for this one because we haven't used this variable until now, right? So now what this isSafe does is if it finds red, right, it's going to traverse to all the red connected red colors before it jumps out of the function, right? That means now let's go down here and then to bands plus plus and then just return bands. All right, so now what will happen if we uh, print total bands and then pass the BMP image in there? Let's also do this and then compile this. Okay, so now let's see the output. See, so we have 2, right? So it says 2. Now let's modify this. Let's modify this color. I'm going to use this line and then use green color for now, and then make one more stripe and then color it. I'm going to save this. I don't know which country's flag this is, but for now all we're going to do is we're going to check the number of bands. So we have 3, right? And that's perfectly right because we have 3 bands. Okay, so now we found out total number of bands. There are a lot of things that we still need to do. So what we're going to do now is we'll have to find out whether that color is okay. We already know the color type, right? So we'll have to find out what kind of band is it. Is it vertical or is it horizontal, right? So that's something we need to find out. So let's do this. So for that, I think we also need to store the value of the pixels starting and the ending pixels. We're going to assume that all the flags that we're going to use or we're going to check is rectangular in shape, right? Like for example, the flag of Japan, it has circle in the middle, right? So we are not going to deal with that right now. All we're going to check is we'll only be able to detect flags that has rectangular stripes, okay. So for that one we would need a structure that can store 4 values. Let's call it rect, and let's say color range. Okay, now we don't have this structure called rect. I'm going to create another structure called rect now, and so all it stores is x1, x2, y1 and y2. All right, I'm going to squeeze that in one line so that the program doesn't become that long. So now if you go back to the band, we'll have to create another function, structure called, okay, let's just call it R for now, I guess. Or what could be the better name for that one? Or okay, let's just call it color rect. All right, now what we're going to do is we're going to save color rect dot x1 equal color rect dot x2 equal I, right? And then color rect dot y1 equal color rect dot y2 equal z, right? So first we're going to assume that our rectangle is 1 pixel, I mean 1 pixel in height and 1 pixel in width, right? So once we enter inside the DFS function, then we're going to find out the actual size. For now, we're just going to assume that it's that it's that big, right? So now what can we do is once we go inside the DFS function, we can check if which color is the gray. I mean, like if the farthest x we have been to and the farthest y we have been to, right? So if the current value of I is greater than cp dot color range dot x2, right? X1 is the initial value. Then what we're going to do is we are going to update the color range dot x2 by I, right? And we're going to do same thing with j as well. If j is greater than cp dot color range dot y2, then cp dot color range dot y2 equal j, right? So we just want to update the maximum x and the maximum y the function has traversed through, right? So by the time we come out of this function, we know that the initial value of x and y, and then we also know the final value of x and y, right? So now how can we use this function to find out whether it's horizontal or vertical, right? So the thing we can do is we know this value and we also know this value, right? So if you see this one is a horizontal stripe, right? So the width is greater than height in horizontal stripe, right? So what about the vertical one? In vertical stripes, so the height is greater than the width. So we're going to use the same logic. So let's call it temp width. So temp width is going to be color rect. Is it color rect? No. So it has to be CP because we've updated the CP color range. Oh, we haven't done one thing over here now. CP dot color range is equal to color rect. We also need to update this, right? Okay, so now CP dot color range dot x2 minus cp dot color range dot x1. So this one gives the width, right? So and then we're going to have temp height cp dot color range dot y2 minus cp dot color range dot y1. So now what we can do is if temp width is greater than temp height, then we know that it's a cp dot is vertical equal false, right? So because width is greater than the height, else cp. Now the code is a little confusing because I'm not using any. Maybe I should do this so that it's more readable actually. Okay, So now we also know that now we have stored more information. Now we know how many bands are there and what's the orientation of each band, right? So we know there are red, white, and green color band, and all of those are horizontal. So we can find that from this thing, right? So what can we do now? So let me think. Mm. Okay, let's do this now. We'll have to store, because color properties, this thing, color properties is going to change for every color, right? So we'll have to store all of this information. So let's make another vector for color properties, right? So let's create a vector color for color properties, and then we're going to call this CP effect. Why? Because we'll have to store all of this information. So how do you do that? So once everything is done, we're going to update CP effect, push back, and we're going to pass in CP in here. Okay, and I don't think we need bands right now. Instead of band, maybe we'll have to pass in color properties now, so that from the functions below we can find out the information of the vector. Now this one is not going to work anymore, since this one has, okay, let's call it from color properties, CP equal total bands BMP, right? And let's traverse through all the colors and then check the properties. CP dot size plus plus I. Now let's check if everything is working fine. All right. So what can we do? We can check CP I dot we have is vertical, right? So first let's find out the color type. Color type. Now this will be confusing. Let's also create another function to give us the color type, right? So what we're going to do is we're going to create get color string function, and then we're going to pass the color value in here, and what we're going to do is if color value equal red color, then let's return red, right? Else if color value equal green color, then we're going to return green. Else if this is going to take too long, blue color, then let's return blue. Let's do this for the last time now. Else if color value equal white color, then return white. Else return unknown color. Okay, so now if we go down, what we can do is we're just making our life easy actually. So get color string, right? And we're going to pass the function and the line. So this will give us the color type, and let's not end it over here, maybe, and let's give a space and then CPI dot, we're going to find out if it's vertical or horizontal, right? Is vertical, right? And then end, right? So let's check if everything's working fine. Ooh, okay, so 7 warnings. I don't know why we have 7, but anyway, let's run this. Okay, red 0, white 0, and green 0. So what does this mean? 0 means vertical, right? White means so we have red, white, and green. So if you go back to this, so we have red, white, and green, and then what we see is that red, all of these are vertical. Oops, no, is vertical is false. So all of these are horizontal colors, right? So let's try to tweak this. Let's copy, no, not this one. Let's take this one and then make this wide, and then let's draw one rectangle in here. Okay, and oops, maybe, yeah. And now if we do this, one thing we know is now the green one is vertical, the red one is horizontal, and then the white one is horizontal, right? So let's save this, go back here, and then compile this. So green one is vertical, so this one is 1. Red one is horizontal, so it's 0. White one is horizontal, so it's 0 2, right? So all we gotta do is now almost everything is completed. All we gotta do is we're gonna use this to find out which flag it is, right? So now finally what we're going to do is we're going to create a final function to detect the flag. We're almost done. I think this video is going to be too long. Okay, let's go back and then create one more structure, I guess, to store the information of the flag. So we're going to call this struct flag information, and what we're going to do is we're going to create the vectors of colors, because we don't know how many bands the countries will have, right? And then we're going to pattern is for whether it's vertical or horizontal, and then we're going to store the name of the country. All right, so now what we're going to do is we're going to use these information, the information in structure, to define our information of the flags down in the main function. For that, let's do it over here. Let's create a vector of flag information. I'm going to call this fi, and fi dot push back. So first one is the vector of okay, so this one is tricky. How should I do this? Okay, so push back is a function, right? And then the first one, so we're going to have the structure inside this bracket, and inside this bracket we'll have to have a vector, right? So what we're going to do is we're going to, I know some of the flags and what kind of colors the stripes in their flag have. So the one I know is Bulgaria. So the first one is white color and the Bulgarian flag, and then the second one is green color, and then the third one is red color, right? And all of these are horizontal, right? Oops. Whoa, okay, so it'd be easy if we just define this one as well now. Bulgaria. Okay, so let's go up here and then create two macros. Define horizontal. We're going to call this maybe, I don't know, since is vertical is 0, I guess. Ooh, let's just call this horizontal maybe 0, and then for, because that's what we saw over there as well, for vertical we're going to call this 1, right? So now if you go back to here, this will work. I think this will work as well. So let's copy this, and then we're going to use one more flag that I know, but this one should be, I think, the vertical one. So let's change this. So if we have the green one here, and then green, white, and red, green, white, and the last one is red. So, and this one vertical, I think this one is Italy, right? And then let's create one more. For this one, I think we'll just create the one with only 2 stripes. So let's call it red, a red stripe, and then the white one, and this one will be horizontal, and this one is of Indonesia, right? So now we have 3. Let's see if this is working. Okay, perfect, this is working. I'm not going to worry about warnings right now. So now what we're going to do is we're going to use the information of all these color properties to find out the flag information. So for that one, I'm going to create another final function, I guess. Detect country, so BMP and BMP, and what else do we need? So we need now flag information, right? Flag information, let's call it FI. All right, and okay, so what do we need? Okay, so we gotta take the total bands BMP, and what we're going to do is total stripes is CP dot size, I guess. Yeah, so it has to be, so now this one gives the total number of bands, and then the size of this these color properties would just give us the total number of bands that the color have. And what we're going to do is I equals 0, I less than fi dot size. So what we're going to do is now we're going to traverse through all this information, these 3 information. We could add as many country information as we want, right? So without modifying anything later on. So for now, we're going to go traverse through three because we have 3 information, right? And what we're going to do now is we're going to extract the color values. So what we're going to do here is colors equal to fi dot colors, right? Okay, now this one might be tricky too, I guess. So let's call it, so we need another one to traverse through the colors. So one thing we got to do is if colors, I mean the colors from this one, if this colors, right, total number of colors that size is not equal to the number of bands we got from our image, right, then we don't need to check if this is the same country or not. We just go with another country now. We just want to check another country. However, if the number of band matches with this one, what we're going to do is we're going to traverse through colors.size and then plus C and then compare each color, right? So how are we going to compare each color? So we're going to see CP dot is vertical equal FII dot, what do we have, pattern, right? Pattern. So if this matches with the pattern, for now we're not going to check individual pattern. So what we're going to do is all these colors, we're assuming that, like this kind of flag, we're just assuming that this kind of flag doesn't exist. So we're just going to assume that if a country has horizontal stripes in the flag, then all the colors will be horizontal, and if they have vertical, then all colors will be vertical, just to make things easy. Later on we could tweak this. It's just about structuring the just organizing the structure. Everything is all done, so maybe that could be a challenge for you guys as well. How do you tackle that situation, right? And what else do we need to check? We also need to check if colors, oh my god, this is getting confusing now. What is this colors? Colors is the colors from the stored information, right? So colors, this color is equal to CP is the color properties, something from our image, and then we're traversing through, and then the color type. And if this works, yeah, then we're going to continue again. Okay, so now this continue and this continue is different. What we're going to do is, this one is for the total number of stripes inside a flag. This one is for, going through, traversing through another information. Like there are three flag information, right? And for each flag information, there are also stripe information. So this for loop is going to traverse through these different country flags, and this for loop in here is going to traverse through the different stripes, right? And what we're going to do is, if C is equal to colors dot size, if it traverses through all those, then we know that we found the country flag, right? Otherwise we can just return -1, right? Let me see if this is working. Fingers crossed. Let's delete all this, and then we're going to name it index equal to, what did we name? It's detect country, right? Detect country. We're going to pass in BMP. Is that all we need to pass? Yeah, and then we also need to pass the flag information. All right, so what we're going to do is, if index equal -1, then we're going to say out unknown flag detected, else out country equals to FI, right? Index dot the name of the country. Right, let's check if this is working. Fingers crossed. Okay, 2 errors. What's not working? Detect. Okay, so let's delete this. Is this working now? One more error. One more error. What is it? What is it? It's like C++. What is this error? What is this error? I don't know. What kind of error is this? What does it say? Converting constant to string. What is this about? Or should I just go and then change this one to const? Let me just name this const and then see. Okay, one more error. What's there? Okay, it's vertical. It has no CP. What's CP? Okay, total band. Okay, total band has CP. Oh, okay. So we forgot to index in here. Finished. Let's check. Bulgaria. How is that possible? Okay. I understood it. So white, green, and red, right? White, green, and red is there. So all it's checking is it's only checking for we're only checking whether it's vertical or horizontal, right? So this kind of things are not invalid. Our program won't be able to detect it. So what we're going to do is we're going to do this, save this, and then go back and then see if our program works. Okay, so this one is working. So this one says that the country flag is Indonesia, right? Let's modify it. So white, green, and red should be Bulgaria, right? So white, green, and red. Let's white, green, and red. Let's take this. Let's make this one green. Let's take the red one. Let's take the. We also don't care about ratios here. Let's go and then run this again. So now this says Bulgaria, right? Perfect. Let's check with the vertical one. So green, white, and red should be Italy, right? So let's make this white. So green, what was the color? Green, white, and red, right? Let's go back. Green. This green should work as well because all we're checking is which value is more in there. And green, red, and green, white, and red, right? Let's use this one. Green, white, and red. So if this one works, then it'll probably work with any flag. Let's save this and go back and then run this one more time. Oops. Why does it say Bulgaria? Is it because this screen is not working? Let's check for this screen. Let's check the values. It should work. Anyways, let's just change this and then go back and then see. Why does it say Bulgaria? Why does it say Bulgaria? Why does it say Bulgaria? It shouldn't. Okay, let's go back and then check in there if we've missed something. Okay. So if it doesn't work, right, So if it doesn't work, then something we need to do is, let's say the country matches. I mean the if it's vertical, then perfect, right? And if it's and if the color also matches, then we continue. And what are we doing if it's not matching? Still it's continuing, right? This condition doesn't make sense at all. So what we got to do is, if it doesn't match, then we just need to get out of that loop, because it's not that country anymore, right? So now let's check it. Okay, so now if we go Italy, yo, it's working now, right? So this is it, guys. I know it's a little confusing. It's like 150 lines of code, but more than how many lines? I think once you understand the basic working behind the DFS, how DFS function works, you should be able to make this program, right? So, and if you want to add more country information, all you got to do is you just need to copy and then add another information, right? For example, let's do one more country flag. Let's paste it, right? And then this time let's make it maybe Austria. So Austria is red, red, and then it's white, red, white, and then it's red, okay, and then so it's red, white, red, and then the country is Austria, horizontal stripe, right? Let's go back. Red, white, red. Let's take the rectangle tool, red, red, white, and red. And let's save this. Let's go back and then run this. And then we have Austria, right? So yes, this works. All you got to do is just add in the information, and then this function in here is written in such a way that once you add in the information, you don't need to change anything in there, right? So if you want to copy this, I know it's a little difficult, but I think you learn better that way. I guess if you just can't copy it in one go, then you'll have to think and then understand the program as well. So I hope this was interesting for you guys as well. Thank you so much for bearing with me, since I guess it's more than an hour now. It's almost